All right, thank you, Terry, and good morning, everybody. This morning, I'm going to talk about a pilot study that's a part of a larger project, and it is the results from the modeling exercise that has been completed for the Upper Peace area of Alberta. So I'm not going to do my usual 5 or 6 slides on NRV. I think most of you know what I'm going to say already, but in any case, just as an introduction, why would anyone want to use natural range of variation? A lot of it had to do with the fact that what I call a value-based approach by itself doesn't work. To be managing complex ecosystems by one value or one species at a time. We've had a lot of experience with that. A lot of it has been negative. And so the alternative that arose in the late 1980s from a group of smart people was ecosystem-based management. And the idea is to use historic ranges to help guide management actions and direction based on the distance from historical precedent relative to where we are now, and maybe even more importantly, understanding how ecosystems work. And the point of this that I'm going to make in this presentation is whether or not you think that this approach is a good idea, the theory is still useful and it's relevant. And I'll show you something that I came up with a few years ago. So here's the theory in action. From the green bar here that has NRV in the middle of it, as you move away from it in any direction, the theory is that your biological risk, and it could be of losing species, losing a function, increases. The probability of being fully sustainable, and by fully sustainable, I mean sustainability of all goods and services, and some of those may actually even be ones we don't even recognize now, could be species that we haven't even named, and how landscape health and resilience is going to decline as well. So there's going to be implications there for climate change. So this isn't a new idea by any means. The CBFA, Canadian Boreal Forest Agreement, Forest Stewardship Council, FSC, provincial rules, the idea of using NRV is embedded in all of these. But I think it's interesting in the land use framework document in Alberta, it's got several key phrases in there that I key in on. Including in the vision statement is a respect and care for the land as the foundation. One of the 3 desired outcomes, healthy ecosystems and environment. And they talk about a land stewardship ethic. And I think this is interesting because it speaks exactly to what EBM essentially is all about. So this project, what we're talking about is the historic range of landscape scale patterns, and I'll describe what that means in a minute. This is a part of a larger project, as I described, and it's called LandWeb. And LandWeb has 15 partners across 5 provinces and territories and covers about 130 million hectares. As a part of that, there were 3 pilot studies, all of them completed now, and this one is the last one for the Upper Peace area. So what's a landscape scale pattern? There you can have non-spatial or spatial. The non-spatial is generally just sheer numbers of the amount of forest in different seral stages, young, immature, old, and it can be captured as an average, a median, the maximum, the minimum, the range, a confidence interval, all of these things, maybe even all of them, because you want to capture the range, and do it by different spatial unit. And by that I mean, it could be done for an individual FMA, it could be done for a park, it could be done for a natural subregion, it could be done for the entire province. In terms of spatial patterns you might want to capture, they might include the size of the various patches, and a patch could be defined by age, could be defined by vegetation type, the amount of edge, the edge density, or interior forest. And those are the simple ones, and those are the ones that most people talk about, and we're just going to focus on a couple of these in this presentation. So, defining NRV, first of all, it has to be pre-industrial, and that rules out a lot of data. We've got a lot of information about boreal and mountain landscapes over the last several decades, but it has been impacted by anthropogenic activity, including fire control. So the pre-industrial requirement rules out a lot. For NRV, time and space are pretty intimately linked. So if you're looking at something very small, it can happen in days. In a watershed, sort of, the dynamics happen over years. And for landscapes, it happens over decades. So at fine and intermediate scales, we can actually create some NRV with empirical data. It's out there. We have to dig for it. But at coarser scales, because the dynamics happen much more slowly, at best what we can do is we can recreate maybe one pre-industrial landscape snapshot, and that doesn't represent the variation part of NRV. So we model, and essentially all we're doing in this case, we're just trying to create more data. We're trying to create more landscape possibilities, and we're not modeling into the future. We're taking what we understand about fire regimes, about how often, where, what, and how fires burn over time and space, and using that with spatial maps to create possible historic landscape snapshots. And then if we get hundreds of these, now we have enough data that we can capture these metrics we're interested in. So that's all we're doing in this case when we say modeling. So here's just a depiction of that. The model input in this case are things that we understand about the disturbance regime, the frequencies, the size, the severity, the shape of fires. And what we're interested in are these landscape conditions. So the zero stage levels, the patch size, and so on. So in a nutshell, that's what we're doing. Now to our study area. This is a really interesting part of Alberta because of the range of ecological conditions, and it also means a huge range in what I call the long-term historic fire cycle. This is a map that was generated over a period of about 3 years with a group of professionals, experts in fire behavior, many of them from Alberta. And these numbers reflect the average number of years of a fire cycle before pre-industrial times. So you can see the range just within this study area of the upper piece. It goes from 20 years on the grassland to 140 years up in the subalpine. So this plays a really important role in the results that you're about to see. So just a quick overview of how I'm going to present the results, because I'm going to do it in quartiles, because as you'll see, it's an efficient way of doing it. So here is a frequency distribution of the results from some of the modeling, and this is just young pine across the whole upper piece. And so the frequency distribution tells you, what the model captured. So the model never found anything less than 1% of young pine. And it never found anything greater than 60%. And this black arrow here tells you where you are today, okay? So there's the frequency distribution from 100 model runs, or 100 samples of model runs, and there's your NRV of the percent of pine that is young, okay? So what I've done is if we divide this up into quartiles, and quartiles is 25% of the data, then here's what it looks like. And you can see that the bands are going to be uneven, and that has to do with the shape of the distribution. Okay, so 4 quartiles always equals 100%. So here in the bottom, this under zero stage, you'll see young. So these green bars here represent the different quartiles. So the one on the left, the light green one on the left, is quartile number 1. The dark green right to the left of the black bar, which is the median, that's quartile 2, quartile 3 to the right of it, and then quartile 4 is on the far right. And you can see sort of how these dotted lines show they sort of line up. And then the current condition is this little red dot, okay? So here's the 4 frequency distributions. So instead of showing you four pictures, 4 images, I'm going to capture it all in one. So what happens here is in this historical range of pine for the upper piece, for every single run, they're always going to add up to 100%. So these red dots here, the current condition, if you add those up, they're going to add up to 100. The medians, which is the black bars, they're not going to add up exactly to 100 because it's a median instead of an average, but they'll be close. So you get a snapshot of what's happening with pine in one image. Okay, so this is what all of the rest of the results are going to look like. So here is all of the forest, 5.6 million hectares for the upper piece. And young is less than 40, immature 40 to 80 years, mature 80 to 120 years, and old is older than 120. So this is a pattern that I'm going to describe now that you're going to see throughout the rest of the results. Okay, and the 2 things I want you to focus on is that this red dot here, the current condition of young, is way over on the left-hand side. If I recall, this is in, I think, the 3rd or the 4th percentile of NRV. So it's really close to being outside of NRV for young forest on the low end. So disturbance levels, you know, for at least that 40-year period have been very, very low. The other thing I want to draw your attention to is the red dot way out here on the right-hand side of mature. Mature being 80 to 120 years. So this is saying that there's an unprecedented amount of mature forest overall on this landscape. Now the amount of old you can see is sitting right on top of the median, and think, okay, well that's pretty good news. But if the red dot here for young is going to stay there, then it's a really simple accounting exercise that tells us that the red dot for the mature is going to eventually and very soon move into the old. Okay, so if we add together mature and old forest, mature, so every the forest greater than 80 years of age on this landscape, I believe it's in the 97th percentile. Okay, so it's right on the very, very upper edge of NRV. So that's all forest. So let's take a look at what happens within natural subregions. Here's the central mixed wood, similar pattern. You know, the amount of young forest is down around at 10% here today, which is very close to the edge of NRV. We've got mature forest here on the upper end as well. So again, another similar pattern. The dry mixed wood is an interesting area. I'm not going to spend a lot of time on it because a lot of this has actually been converted to agriculture. So there isn't as much. There certainly isn't 1.5 million hectares of forest in the dry mixed wood. That's how big the dry mixed wood is. But you can see what forest is there, how out of balance it is. Lower boreal foothills, again, a similar story. That mature forest dot way out on the right, and the current condition of young forest over to the left. So same thing for lower foothills. Similar for the subalpine. Upper boreal highlands. Actually, it's interesting, the upper boreal highlands, the amount of young forest is very close to the median. And I'll talk about this in a little while longer. This is an area that has been more managed than other parts of the landscape. But you still have a big clump of mature forest out on the right. Oops, and then the upper foothills, similar pattern. So that's just for the, I didn't break it down by species in the interest of time, but what I did is I broke the results down into other things I thought you would be interested in. So this is the NRV and current condition for the Alopesh range of the upper piece. So just that part of the Alopesh range that's in the upper piece, not the whole Alopesh range. So a similar pattern here, not much young forest, and the mature forest is getting close to the edge of NRV. But what's interesting here is this purple bar at 35%. That represents sort of the threshold defined by Environment Canada for recovered forest. You want to have at least 65% of the range that's at least 40 years of age. And in this case, the model runs achieved that 29% of the time. Okay, so just to be clear, so the other way of saying that is that 71% of the time from the historic model runs, there was not enough recovered forest as per the Environment Canada guidelines for caribou. Okay. Here is the Chinchaga range, and in this case, because the Chinchaga is in an area relative to the Alopesh where the fire cycles, historic fire cycles, are longer, 69% of the time, which I think is the highest that we found, it met the Environment Canada guidelines. And you can also see the red dots are far below this 35% level. And again, just to be clear, for these, I am not counting for any buffering from the edge of disturbances or features. This is purely just the amount of forest at different ages. Okay, so it's don't take this as, you know, the caribou range is fine. What I'm saying here is that in terms of the percent requirements, there's something really interesting going on because, you know, in this case, 40% of the time it met the requirements. So the other 60% of the time it didn't. So it, you know, and that begs the question, what are we missing? What don't we understand about caribou that isn't in the requirements in the model right now? The narrow way, 59% of the time. And Red Rock is the last one. Okay, now here I have had to borrow from CAN4's results, and I know there's some CAN4 folks there, and I hope you're okay with this. But this is an important distinction here. So what CAN4 did is provide me with a layer that differentiated the active land base from their passive land base. And I created NRV and compared current condition in each case. And not surprisingly, we find that in the active land base, the amount of young forest is still on the low end, but we're up around 18, 19%. Okay, if we go down here and look at the bottom graphs on the passive land base, we're only at about 7 or 8%. And that's, again, not surprising that we're not actively managing that part of the land base. Now, let's take a look at mature and old for each of them, because this has been a pattern, of course, for decades. That you know, so the only disturbance that's happened on the passive part of the land base has been incidental anthropogenic, and of course, whatever fires we haven't managed to put out. So on the active land base, the mature is on the high end of NRV, and the old is within the middle two quartiles, in the third quartile of NRV. And on the passive part of the land base, they're both outside of NRV. So, and again, and we take a look at how little disturbance there has been, we project this forward in time, and these red dots in the mature and the old and the passive are only going to keep shooting out to the right. Okay, old forest patch size results. I'm only showing I'm only going to show old forest patch sizes here again in the interest of time. Um, and I'm just going to show you 2 or 3 of these graphs. So small old forest patches, and let's say less than 50 hectares, here's the number that existed on the landscape. So we're moving back to a frequency distribution. So there was always at least 8,000 of these small old forest patches, and there was never more than, let's see here, 15,000. And right now we're sitting at about a little over 14,000. So we're on the high end, but within NRV. And remember, we have a lot of old forest, right? So now we'll look at larger patches. So in this case, I used 1,000 hectares. So today there are on the whole Upper Peace landscape, there's about 35 patches that are larger than 1,000 hectares, which was never observed historically. Historically, the number was from about 45 to about 155. And if we go up to 5,000 hectares, we don't have any on the landscape. Then you can see that historically there was, anywhere up to 50. So what's actually going on here? And remember, there's lots of old forest on the landscape. Okay, so this isn't due to too much disturbance. This is due to the way we're disturbing. And of course, the logical explanation is that it's going to be anthropogenic activities, and a lot of it's going to have to do with linear features. Another study that I was a part of with a grad student showed, for example, the impact of the energy sector on metrics like this was much more influential than forestry activities. So this isn't a matter of we're disturbing too much. This is more an issue of we're disturbing inappropriately. Okay, the last thing I'm going to show you, and I've never done this before, so I thought I'd give it a try. I used actually the breakdown of the CAN4 data again here, but it's the exact same pattern for any species type breakdown that you would use. So what I did here is I calculated just the amount of area in each of these ecotypes. And in terms of an ecotype, I've simplified it to it's a serial stage by a species type. And if you don't have any more specific information, most jurisdictions revert to this and call them ecotypes. And it's sort of think of it as a surrogate for different habitat types on a landscape. And again, what you want to see here is mostly green. You want to see, well, historically, this graph would all be green. And what I've done is I've color coded them. The middle 2 quartiles are the dark green, and you can see there's not a lot of those. And then the outer 2 quartiles, but I use the 95% limit, would be the light green. And then the different shades of red means that they're outside of NRV. So out of these, only 50% of the ecotypes are within NRV today. And that's only 25% of the landscape by area. Okay, so the point I'm trying to make here is that this is a landscape that's out of balance, and it's not, and the obvious thing that to focus on is how much old forest there is now and how much old forest there's going to be in 10 or 15 years, and it'll be overwhelming. And of course there's going to be consequences associated with that, and I'm sure, as everyone is already thinking, that the most obvious is the increase in threat of wildfire and mountain pine beetle and disease is going to be very real, not just on this landscape, but everywhere. But I also want to talk about what else the imbalance means. And so, for example, let's take the young forest. We're talking about habitat types that have become marginalized on a massive scale. So just take this, young black spruce, the 3,000 hectares that's sitting in there now. If we take a look at the median of NRV, it's about 48 to 50,000 hectares. So we've almost eliminated a habitat type, and our focus on old forest sometimes doesn't do us any favors, and we tend to think of it as that which we should be protecting, and it's got high biodiversity values. But guess where the highest level of diversity is on a landscape? It's on forest that's less than 10 years of age. Not old growth, not in the boreal. It's young forest, and they're unique species and unique services, and that's something that we could be sacrificing, and we might not be aware of it because we're not even looking for it. So from a landscape ecology perspective, that's why I say this is a landscape that's out of balance. And if we forward this in time, another 20 years business as usual, there's going to be a lot more red. And the only reason it would stay in green is if harvesting increased substantially, harvesting and prescribed fire increased, or we get some really big bad fires, right? So I think, yeah, so here we go, back to this diagram. So distance from NRV, I think we can all agree that this is a landscape that's already moving to the right. And we can start to see what some of the risks might be associated with that. And we probably have enough information to project this forward in time and talk about what else is going to happen to this landscape that we're not seeing right now. So what's going on here? Is it too much disturbance? Absolutely not. One of the problems is not how much disturbance we're putting on the landscape. It's the details of how we're doing it, right? That's the problem. So imposing something like a disturbance threshold isn't the answer. We've got to be smarter about how, where, and when we put disturbance on the landscape over time and space. And so this all comes back to the idea of, this is a useful concept, because comparing this to NRV, seeing where it's outside, and then connecting the dots isn't rocket science to understand what's going on. But what is surprising, and even surprised me, is how far this landscape has moved beyond NRV already. And so it's only going to keep going in that direction, as far as I can see.